Hello everyone. In this video session, I am going to practically demonstrate a Java program to implement quicksort algorithm. So what exactly is the quicksort algorithm? Let me explain. Let's say there is an integer array like this. In this integer array, there are several integer elements. As you can see here, all these elements are in some random order. They are neither in ascending order nor in descending order. They are in random order. Now, if we have to sort all these array elements in ascending order or descending order, there are several ways to do guys. But in this session, I am going to use quick sort algorithm for sorting all these array elements in ascending order. So before I implement or write a Java program to sort this array elements in ascending order using quick sort algorithm, first let me explain what exactly is a quick sort algorithm. So theoretically, let me explain it first. What exactly is a quick sort algorithm? So for that, so we'll take out this array elements. That is here we have 50, then 25. These are the array elements, right? 50, 25, 119. Then we have 41, then 62. The next element is 21, then 65. Then we have 84, then 33 and 21. 33 and finally 21. These are the array elements. So according to the quicksort algorithm, what we'll do is we'll make this first element as a pivot element. Okay, you can make any element as a pivot element guys. Some generally people consider middle element or edge elements like last element or first element as a pivot, but I prefer taking the first element as a pivot element. So here I made 50 as a pivot element. Done. So this pivot element I will compare with the remaining elements. Once I make an element, first element as a pivot element, I will compare this first element with the remaining elements. So before doing that, what I will do is I'll actually take this pivot element here, guys. Let's say I'll put this 50 here, somewhere here. Okay, this is a pivot, right? 50 is a pivot element. So when you compare the next element 25 with this pivot element, what you will do is 25 is less than 50. Okay, when something is less than 50, you'll put that into the left partition. So it's a simple concept, guys. You're comparing this pivot element with the remaining elements. If these elements, when you are comparing, they are less than or equal to 50. Okay, if any of these elements are less than or equal to 50, then you have to put in the left box. If any of these elements are greater than this pivot element, considered pivot element, that is greater than, then you have to put in the right partition. So when you compare 25, 25 is less. So 25 will go to the left partition. Less than or equal to, it will go to the left partition. 119 will go this side. Then 41, 41 is less than 50. So 41 will come here. Then 62, 62 will go here. Then 21, 21 will come here. Then 65, 65 is greater than, so it will go here. Then 84 also will go here because 84 is also greater than 50. So like that we'll compare remaining elements with the pivot, and if they are greater, we'll put into the right partition. If they are less, we'll put into the left partition. So then we have what left, guys? 33 and 21, right? 33 and 21. Since they are less than the 50, less than or equal to 50, they will come to the left partition like this. Now we'll repeat the same process. We'll put the pivot here itself, and we'll repeat the same this kind of quicksort algorithm process of considering first element as pivot and comparing, right? We have to do it recursively, guys. For left partition also, we have to repeat the same thing. So what do we have to do? Again, we have to make the left partition, we have to make 25 as a pivot. Okay, this one we are making as pivot. So when you make 25 as pivot, 25 will come into somewhere here, and we'll put that here 25, because I'm making this 25 as a pivot, right? So here in this left partition, I am making 25 as pivot. So when you compare remaining elements, if the remaining elements are less than or equal to 25, they'll come to the left box. Otherwise, they'll come to the right box. If they are less than or equal, they'll come here. If they are greater, they'll come here. So 41, 41 is greater, so it will come to the right partition box. Then we have 21, 21 is less, so 21 will come here. 33, 33 is greater, so it will come to the right side. 21 again less, So it will come here like this. Done. So coming here to the right partition, again here also we need to consider one element as a pivot. So we are considering 119 as a pivot. So I'll put this 119 somewhere here. So 1119. I'm making this 119 as pivot. So when you make 111 as pivot, again you need to put two boxes, left box and another one is a right box, like this. Right box and left box. So when you when you compare 119 with the remaining elements, all the elements are less than 119, right? All these three elements are less than 119. So they'll come to the left box. In the right box, no elements will be there. So here 62 will come, then 65, then 84, right? Remaining elements came here, done. Now we'll repeat the same process for these boxes also. We'll make the first element as a pivot. Okay, so 21 came here. 21 became the pivot. And when you compare 21 with this 21, 21 is less than or equal to 21. So it will come to the left box. To the left box, what will come? Left and right boxes, right? So when you compare this 21 with 21, 21 is less than or equal to. If it is less than or equal to, it will come to the left box. If it is greater, it will come to the right box. So 21 is less than or equal to, so 21 will come here. 21 will come here, and on the right box nothing will be there. Okay, like this. And what about this one? In this we'll make the first element, that is 41 as a pivot. So 41, let's say 41 is there, is here, and this is pivot now. And left and right boxes, left and right boxes of 41. So when you compare 33 with 41, if it is less than or equal to 41, less than or equal to, it will go to the left box. Otherwise, if it is greater, it will come to the right box. So 33 is less than or equal to, so 33 will come here. No element will be there in the right box. Done. Now what about this box? So here we'll make 62 as a pivot. So somewhere here I'll put 62. 62 is a pivot, and left and right boxes we have to put left and right boxes. So when you compare 65 with 62, 65 is coming here because 65 is greater than 62, and 84 greater this box, less than or equal to this box. What about 84? 84 is also greater, so 84 will come here. Done. And this will continue with one more iteration where you see individual elements are there, 21, 20, everything is like individual now. Either they are pivot or this one has only one element. Now only this one has two elements. So here I'll make this one as pivot. And when you make that as pivot, 65 has become the pivot, and two boxes will come. So when you compare 84 with 65, if it is greater than, it will come to the this box, right partition box. So all elements almost okay. We are left with single elements in the arrays, right? So what we have to do is we have to start from left side. So here 21 is there, right? 21. At the end of this recursive way of applying this quicksort algorithm by using this pivot concept and partitioning, so we'll get this result as 21. Then we have pivot, that is 21 pivot will come here. After 21, 21 pivot will come. Then after this 21, we have 25 pivot, right? 25. So 25 will come. Then after that, okay, pivot we are not going to touch. Once it is pivot, we are not going to touch. Remaining elements only will keep on doing. So here then 41, 33, once you make 41, right? 33 came here. So 33, next item is 33. So here 33. After 33, we have 41 pivot. So 41 is the next item. So after 41, the initial pivot 50 is there. Then after 50, we have this one need to be done. So still not done. 62, 62 is a pivot here, right? After 50, 62. You see 62, then these are getting divided. So 62. Then after 62, we have here 65 as a pivot. 65 as a pivot. 65. Then we have 84. 84. After 84, after this left side is done, then we have 119, right? 119 on the right side of 119, nothing is there. So 119 is the last element. So if you can see this list now, do you see all the array elements got sorted in ascending order or not? Right? Because of this quicksort algorithm, by applying this quicksort algorithm with this pivot and partitioning, at the end, you see all the elements got sorted in ascending order: 21, 21, 25, 33, 41, 50, ascending order, guys. This is a theoretical explanation of the quicksort algorithm, guys. Hope you understood it. Now, next thing is, but for implementation of the Java program, okay, but for implementation of the Java program, we need to write some logic, okay, which is adhering to this pivoting and partitioning technique, right? We have to think about a logic. So let me explain the logic also in a theoretical way first. After that, I will write the code, okay, reflecting that. So for writing the logic, I am explaining the quicksort algorithm in this logic way, okay? How we can implement the logic for the quicksort algorithm, I'm going to explain. Fine. So here, first we'll put the array. How many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 partitions. Make 10 partitions. I mean 10 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Like this. 10 are there. So 50 will come here. Then we have 25, 119. So this is for logical explanation, guys. Okay, how to build the logic for okay, writing the Java code for implementing the theoretical explanation of the quicksort algorithm. Just now I explained, right? How to make that possible in a logical way. For that, you need to understand this concept. 21, then 65, then 84, then 33, then 21, like this. So I'll just move it a bit down. Okay, like this. Okay, this is the array. Here we have index 0, then 1, then 2, then 3, then 4, 5, 6, 7, 8, then 9. Like this, indexes are also there. So I will make this first element, you know, right? The first element will be the pivot. This arrow, let's assume that this arrow is pivot. Okay. This arrow is pivot. And we'll also do one more thing, that is start. We'll put the start here and end here. Start is the first element. End is the, I mean, 0th index. Start is nothing but 0th index. 0th index means first element only, right? Representing the first element. Whereas end is the last element. Index of the last element is end. Like this, start and end will put. Now, we'll compare this pivot. We'll compare this pivot element with the start. So 50, start is also 50, right? 50 less than or equal to 50. 50, you're comparing 50 with 50, guys. You're comparing 50 with 50. So since 50 is less than 50, we have to move this start to the right side. Okay. So if 50 is less than or equal to start, start is also 50. At the index 0 also 50 is there. If pivot is less than the element which is there at less than or equal to the element which is at the start index, then we have to move the start to the right side. Like this, we have to move the element to the right side. So start became 1 now. Since 50 is less than or equal to 50, we move the start to the right side. Now the next one, start again we need to check. Start is now at 25. Is 25 less than or equal to 50? Yes, 25 also less than or equal to 50. So start will move to the right side. So start became what? Start became 2, guys. Start became 2. Now start less than or equal to 50. 119 less than or equal to 50? No, right? Start is not. So this is not less than or equal to 50. This 119 is not less than or equal to 50. So start will stop here. Start will stop here. Now coming to end. What about end? End is for end, right? End is ninth index. At the ninth index we have 21. Is 21 greater than 50? When you are comparing the start index value, you have to use less than or equal to. Okay, start index value is less than or equal to pivot. This is pivot. This is pivot. P I am saying. If start index value is less than or equal to pivot value, then start will proceed to the right side. But end index value is greater than, this side we have to see greater than. Okay, end index is greater than, index value is greater than this pivot. 21 greater than 50? No. So end will stop there only. It will not move, guys. Okay, if it is greater than, then it will move to the left side. Otherwise, it will not move. So start has stopped and end has stopped. Now what we have to do is we have to swap these elements. We have to swap these elements, guys. We have to move 119 to this position, 21 to this position. Okay, we have to swap that. So when you swap, what will happen to this 119? So otherwise we'll copy paste this. Okay, so what we'll do is sorry, we'll copy paste. Okay, so this is the current position, right? I'll copy paste. So before swapping, after swapping kind of thing. Control V. I'm just copy pasting here. So here you need to swap when start has stopped and end has stopped. We have to swap these two values. 21 has to come to 119 position and 119 has to go to the 21 position. So let me do that. So in place of 119, this 21 will come. This 21 is getting swapped here. So 21 will come here. And here 21 in place of 21, 119 will come. 119, 119, done. Now again we need to compare. Okay, again we need to check this start with the, after swapping we need to continue again. So start is currently here. So 21 less than or equal to 50, yes. So start will move to the right side. Sorry, start will become like this. Start has moved here because 21 is less than or equal to 50, start move to the right side. Now 119, 119 is greater than 50, yes, this time it is yes. So end will move to the left side, end minus minus, start plus plus and minus minus. If conditions apply, if it is greater than, end minus minus. If it is less than or equal to, start plus plus kind of. Fine. Now, so are we continuing, right? So we have to continue this, guys. Okay, we have not done with this. So here one more thing we have to do is again after start has moved from 2 to 3. So before this end is compared, let's move it back, guys. Okay, let's compare this end later. Start is not done. Start has not stopped it, right? We stopped it. So here from 21 we compared, right? Just now we compared 21 with 50 and we moved start from second to third. Now again this value also we should not start the stop. Okay, we should not stop the start until this value is not othering with this less than or equal to. We have to keep on continuing to the right side. So here 41 is also less than 50. So again start need to be moved to the right side. But 62 is not less than or equal to 50. Now start will stop here. Then only we have to consider end moving. Okay, once start is stopped, then only we have to start comparing the end with the pivot, right? So start was originally there at 21, it came to the 62. Now what about end? End is at this 1919, 119, 119. So 119 is greater than 50. Yes, correct. So end minus minus will happen. End minus minus will happen. So end will move here. Then 33 greater than 50. No, end will stop here. Like the start has stopped. And also when this condition fails, start will stop. When this condition greater than condition fails, end will stop. When they stop, what we have to do? We have to swap. Now we have to swap these positions. Okay, we have to swap these positions. 62 should come here and 33 should come here. Let me do that. So here earlier what we swapped, guys, we swapped like this. 21 came here and 119 came to this last position, right? So let me do it better way. Done. So now we'll take a copy of this. Before swapping, I'll take a copy. Okay, done. So here also swapping will happen, right? Start is stopped here and end is stopped here. So we have to swap this start and stop. So 62 will go here and this 33 will come here. So when they are got swapped in place of 62, this 33 will come. Okay, 33 will come in place of 33. This 62 will come. this 62 will come. Done. Right, 62. Yeah, fine. Now we have to continue the process. Now this start will be compared with pivot. 33 less than or equal to 50, true. So start will move forward. Start will come here. Now 21 is less than or equal to 50. Yes. Start will move forward. Start will go here. Now 65 is 65, I mean, less than or equal to 50. No, right? 65 is not less than or equal to 50. So it will stop here. Start will stop here. Now coming to the turn of the end should be greater than pivot. So 62 is greater than pivot, true. So end minus minus will happen, n will move to the left here. 84 greater than 50. Yes, correct. So end minus minus. Now 65, end is at the 65. 65 greater than 50. Yes, it will move here like this. And we'll move to this position. So now, do we have to swap? We should not be swapping, guys, because here start is greater than end. Till start is less than end, then we have to swap. See the condition here. Here, when we are swapping this 119 with 21, start is less than end. When start has stopped and end has stopped, the start is still less than end, right? End is greater. End is 9 and start is 2. 2 is less than 9. So we can swap. We swapped it. Now, the second iteration where start has stopped here and end has stopped here. Start is 4 and end is 8. 4 is less than 8. So we can swap. But here end is coming here and start is coming here. Is start less than end? 6 less than 5? No, we should not be swapping. This case we should not, no swapping. When start becomes greater than end, no swapping. Like this, guys. Okay? Like this we have to do. Now, here we are not swapping the end and start, but we can swap some other thing. We have to swap, instead of swapping this start and end, here when start is not less than end. When start is not less than air, we are not swapping the end and start. We are not swapping, no swapping of start and end, because start is now greater, start is has become now greater than end. It's not less than end. Until start less than end, we can swap this start and end. But once start is not less than end, instead of swapping this end and start, we need to swap this pivot with end and end with pivot. Like this we have to swap. Instead of swapping this end and start, when start is not less than end, we have to swap this pivot with end and end with pivot. So what happens here? Let me take a copy before swapping. So here, we are swapping pivot with pivot is this one, pivot with pivot with end and end with pivot. So 21 will come to the 50 position. Here 21 will come. And here in place of 21 end position, 50 will come. In place of 21, this 50 will come. So earlier the pivot was 50, right? So what's the main intention of the quicksort algorithm? To move all the elements which are less than or equal to this pivot element to the left side. So just see, pivot element came here to this end position. Are all the elements on the left side of this pivot, pivot, are they less or not? 21 is less than 50, 25 is less than 50, 21 is less than 50, 41 is less than 50, 33 is less than 50, like that. You see all the elements on this earlier pivot element 50 are greater. You see 65 is greater than 50, 84 is greater than 50, 62 is greater than 50, 119 is greater than 50. By doing this kind of logic where you'll continue the start until, okay, you will continue the start until these elements are less than or equal to 50, and decrement the end until these elements are greater than 50. And once start and end stops, we'll swap. We'll do this process continuously until this start is less than end. We'll continue the swapping process. But once start actually is not less than end, then we'll simply swap this end with pivot. So pivot will come to the middle, and all the elements on the left side of the pivot element 50 will be lesser elements. All the elements on the less than or equal to elements, or all the elements on the right side of this pivot 50 will be the greater. This is logic, guys. This is the logic. Now we have to continue this. Now the new pivot is, now we have to continue this, guys. So how to continue this? So here already we have, in order to continue this, we have to break these two things into two parts. We should not be considering the pivot. This we have to exclude. Okay, this 50 is a earlier pivot, right? This will be in the center. So this will become the left partition, and from here to here, okay, after 50 to end of the 50, this will become the right partition. Now again, this process will continue. So here in the left partition, this 21 became the pivot, and in the right partition, 65 became the pivot. We have to apply the same rule, guys. Same, here again start will be there, here end will be there, here start will be there, here end will be there, kind of. You have to continue this process, guys. Okay, pivot, start and end. Here this is pivot, this is start, and this is end, like that. Okay, you're getting the point, right? This will become the end. So here also, to the left partition also, this is start, and this is end. Now this time we'll compare the start with 21. Yeah, it will keep on moving to the right side. So this process is a recursive process, guys. 25 less than, no, stop, end. 33 greater than, yes, end will move to the left side. Same process. And have to move here, sorry. Okay, and I am moving here. Now 41, yes, again greater than 21. So end will decrement. 21. 21 less than or I mean not greater than. So end will stop here. So we'll swap this start and end. Like that, guys, the process should continue for the left partition and right partition. So here again left and right partitions will come. Here also again left and right partitions will come. One pivot element will come in the middle. So as I already explained theoretical portion, right? Pivot, okay, pivot should be considered, and lesser elements will come to the left partition, and less than or equal to elements will come to the left partition, and greater elements will come to the right partition. So this is a recursive process, guys. So how to implement this? How to write the logic? This is how we have to write the logic. By basing on this thing only, we have to write the logic, guys. So now let me write the logic. So initially we have to create the array. So integer array arr is equal to, I'll create the array. So array elements are 50, 25. Initial array elements are 50, 25. Is it 25? Yes. Then we have 119, 119, and 41. Then we have 62, 21, 65, 62, 21. Then we have 62, 21, 65, 65. Then we have 84, 33, 21. 84, 33, 21. Done. So inside the main method, we created this array. Now we'll create one reusable method, that is public void. I'll name this method as partition. So this is for partitioning. We'll write the actual core logic here for partitioning. So to this partition, how to partition this this thing into multiple partitions? Here two partitions happen, right? This is a 50 is in middle pivot element, and left partition and right partition. For this to happen, we have to create this reusable method. Integer array will say, comma, int lower bound, comma, int upper bound. So lower bound, upper bound are the indexes, guys. Okay, here 0 is a, in the beginning 0 is a lower bound, and this end, okay, 9 is the upper bound. Starting index and ending index. Lower bound means starting index, upper bound means ending index. Now here inside this, we have to continue this process of partitioning. So what we'll do here is we will create a pivot element first. Int pivot. Okay, int pivot is equal to, what is the pivot element we are considering? Starting element. So that is nothing but the AR of this lower bound, guys. AR of this lower bound. AR of 0 is nothing but, here AR of 0 is, this is the lower bound, right? I'll put the lower bound here. Lower bound, done. AR of lower bound. Then in start. start is equal to, what is the start index? Initially start will be there here guys, right, at 0. So that is nothing, initially it will be lower bound. This lower bound will be the start. End is equal to, end is equal to the last index 9 is the end. So that is the upper bound. This upper bound, done. Now what we'll do here is we'll create some logic like this. While this array of this array we are passing here guys, okay, understand for now. Let's say this is array, okay, somehow this array will be passed to here. I'll explain later how to pass this array here. I'll call this method sometime later. So when the array is passed, whatever the array is there, so array of this what is that, start, array of start array of start means start will be there here at the 0th index. Initially start will be there here, right? Initially start will be there here, end will be there here. So array of start is 0, array of 0 is 50. Is 50 less than this pivot? Pivot is also array of lower bound, that is pivot is also 50 only. If 50 is less than or equal to, we have to write. You see the condition here is less than or equal to. So less than or equal to we'll write. If it is less than or equal to, what we'll do, if this 50 is less than or equal to pivot, then we'll simply move this start to the right side. We have to move the right side. That means start will become from 0 to 1, index 0 to index 1. For that, start plus plus you say. Initially start will be 0, start plus plus means start will become 1. And again 25 less than or equal to 50. Yes, true. Again we need to move start to the right side. Again we need to move this start to the right side. Done. So that's why I'm saying while this AR of start, now start became 1, AR of 1 is also less than or equal to pivot. So again start plus plus will happen. Start will become 1 to 2. This 2 it will become. Now again AR of start is 119. 119 is less than or equal to 50. Less than or equal to pivot is 50, right? 119 is less than or equal to 50. No. Start will be there at index 2. Start will be there at the index 2. Done. Now similarly, after this, while the start has stopped here, now we have to write this condition. While AR of end is greater than, okay, greater than pivot, we have to say. If it is greater than pivot, then end minus minus. Let's see here. 21. Is 21 greater than 50? No. So end will stop here only. End will be the last index only, 9 only. End will be still this upper bound, that is 9 only. End will be still 9. So once the start and end stops, what we have to do? Once start has stopped at this index 2 and end also stopped at the index 9. It didn't actually move to the left side, right? So now we have to swap. We have to swap this start here and end here. 119 should go here and 21 should come here. That's the thing. So how to make that possible? Here we need to swap it. For swapping, we'll write another method, guys. Here we need to swap the start. AR of start should be swapped with AR of end. For that, I'll create a method, guys. Public void swap. And to this also I'll pass the array. And I'll say int, instead of saying start, I'll say int s. Here int e. E means end. Okay. Like that I'll put. Here, what I'll do is I'll call this method swap of whatever the array, and we have to pass the start index, and end index. Like this, we need to call this swap array. So here we have to say int temp. For swapping, you know the logic, right? We have to create a temporary variable. Now temp is equal to AR of this start. S means start. AR of start. Now to this AR of start, we'll assign AR of end. AR of end index. To the AR of end, we'll assign the temp. So this will do the swapping. Okay. The AR of start will be swapped with the AR of end. When you call this swap method, AR of start will be swapped with the AR of end. That means 119 will go here and 21 will come here. So you see 21 came here and 119 was there here. So it was like this, right? And end is here. After swapping, The thing is like this. Now, okay. So this is only one iteration we did, right? Only one iteration, but still we have to continue. Till when we have to continue this process? Until this start is less than end, we have to keep on continuing the swapping of this end and start. We have to swap this end and start elements when they stop until the start is less than end. When start becomes greater than end, we have to stop, right? So that's why we will put a while loop surrounding this logic. This is only one time we swapped. One time the start has stopped, one time the end has stopped. Now we have swapped it one time. But here multiple swap need to be happened, right? Until the start is not less than end, we have to keep on swapping. For that, we'll put this in the while loop. And while, okay, while start is less than end only, we have to swap. And start is less than end only, then only we have to swap. Otherwise, we should not swap the start and end. And one more thing here is this swapping also should happen when if this start is less than end only, we have to swap. The start is less than end only, we have to make this swap happen. Otherwise, we should not swap. Okay, we should not stop swap. This condition we have to put it here also. If start is less than end, then only we have to swap. Here in the first iteration, here start is 2 and end is 9. So we are swapping it. But in this case, when the time comes here, okay, so when the time comes here, the start has become 6 and end has become 5. Now we should not swap the start and end, right? For that, we have to put the condition here. And this loop should continue until the start is less than end. So this will keep on swapping. Done. Okay, the process is done. While, but at the end of this while loop, when start is not less than end, when the start has become greater than end, then what we have to do, instead of swapping the start and end, we have to swap the pivot element with the end. How to do that? How to do that? Here we need to call the swap after the while loop, and here we need to pass the array. And this is like pivot element is nothing but array of lower bound, right? Array of lower bound. So here you see in the beginning we have written the code. Array of lower bound is a pivot. So array of this lower bound we need to pass. Okay, lower bound. Sorry, this lower bound we need to pass, comma the end index we need to pass, and lower bound will go to the S, and end index will go to the E, and the elements in the lower bound, that is pivot element 50 will be swapped with the end index value, that is 21 and 50 will be swapped because of this thing, like that. So this how we need to swap. That's fine. So at the end, guys, at the end, what we have to do is this is a pivot element. This is a left partition, right partition, right? This is left partition. This is right partition, and this is a pivot. Pivot. Where is pivot, guys? Pivot is at the end. End is there here. Okay, end is there here. End has stopped here at the pivot. So this position we need to return, because next time you are not going to consider this element for comparison. Okay, this 50 is not going to be compared in the left partition or right partition. We should only compare the left partition without 50, right partition without 50. So for doing that happen, for making that happen, what we have to do is we have to return the end index. Okay, where the pivot element is swapped. Pivot element has now moved to the end index, right? This is the end index. So return end we'll say, and return type we have to change it as int. And here one more method we have to create now. This partition should happen recursively, right? For making it recursively happen, we'll create a method like public void sort method. You can give any names, but I'm just giving here. For this method, we'll pass the integer array and int lower bound, comma int upper bound. Okay. So where we'll be calling this partition, I'll tell you. Here from the start, we'll be calling the partition. Now here we'll say we have to keep on partitioning. We have to keep on partitioning until this lower bound is less than upper bound. We have to keep on partitioning until the lower bound is less than upper bound. So why like that? Because so when you keep on partitioning, right, at the end only one element will be there in the left partition and one element may be there in the right partition. Then lower bound is the first index, upper bound is the last index. In case of one element, will the lower bound will be less than upper bound? No, right? Mostly at the end of the partitions, like ultimately when you recursively partition like this, at the end, you will have the left partition having only one element like 21, and right partition may have one or zero elements, we don't know. Okay, like that kind of situation will come. So where if only one element is there in the left partition, if you are trying to apply this partitioning to this single element partition, is it possible to partition more the single element? Can you break the single element into multiple parts, left and right? No, right? So that's why you are putting this left lower bound is less than upper bound. If lower bound is less than upper bound, then only we have to partition, kind of. Now we'll call this partition method, and we'll pass the array, and we'll pass the same lower bound comma upper bound. We'll only partition until this lower bound is less than upper bound. Okay, starting index, ending index starting index should be less than the upper index. Then only there will be multiple elements in the partition. If there are multiple elements in the partition, you see this particular left partition has a multiple elements. Here lower bound is 0, upper bound is 4. So 0 less than 4. Since there are multiple elements, we can continue the partition. But here, when you keep on doing this partitioning, there may be a situation where this left partition may have only one element. Now is lower bound less than upper bound? In this case, lower bound is same, upper bound is same, that is 0 only. 0 is not less than 0, so we'll not partition more, kind of. So this will return integer, guys. This return type here we provided as end index, right? That is nothing but the location, guys, location of the pivot element. You see the pivot element 50 moved to this location of the end index, that is 5, this 5. So 5 will come here. Now using this location we are going to partition. How to partition? Again, we will be recursively calling this sort method by passing the array, and this lower bound will be same. You see, for the new partition, the lower bound is same, 0, right? Lower bound is 0, comma this next thing, that is upper bound will be this pivot minus 1, pivot index minus 1, right? That is end. Here location we are getting from here, right? Returning is end, that is nothing but the location. So location minus 1, location minus 1 means end minus 1, end minus 1 is 5 minus 1, 4. So starting from 0 to 4, this is one partition. Like that, this is left partition. Now sort of, we are sorting the left partition. Again, the same process will continue, guys. When you try to sort right, this partition will happen, and the left partition will be done. Again, array of, what about the right partition? Here we also have to do the right partition, right? After 50, this right partition should be done. For that, here location plus 1 we have to say. Location is this end index. End index plus 1 is 6. So here 6 will be there, comma, and thing will be the upper bound. Upper bound. Location plus 1, comma, upper bound. This is the right index, right partition. So like this recursively we'll keep on sorting this. Recursively we keep on partitioning and sorting. Okay. Fine. So I think we are done with the logic, guys. Now the next thing left is how. So we are calling the partition from the sort method. Now we have to call this sort from the main method. So for that, in order to call this sort from the main method, main is a static method, whereas sort is not a static method. So in order to call this sort, we have to create an object for the class, that is demo. Demo is equal to new demo, and we have to use this object reference demo to call this sort method, demo dot sort. That's it. And we have to pass this array, and we have to pass the lower bound as 0, first element initially 0, and upper bound as last index, that is size of the array minus 1. Upper bound is arr dot length minus 1, that is nothing but 9, guys. Arr dot length is total elements are 10, 10 minus 1 is 9, so 9 is the last elements index. That index we are passing here as upper bound. So once this sort is called, this sorting and recursively this sorting and partition will happen. Okay, recursively this sort, you see sort calling itself, recursively sort will be happening, and inside sort partitioning is there. Partition will also happen recursively, and partition will be calling this swap whenever required. Done. So after this sort is completed, we'll print out the array here. Can we directly print this array like this? It's not possible, guys. We cannot directly print the array in the println statement. So what we have to do is we have to convert this array into the string. How to convert the array into string? For that, there is a predefined class known as arrays, and there is a predefined method known as toString. And to this toString, we need to pass this array arr, kind of. Now save this. Now here array got converted to the string, and then we are printing that string with the help of println. Let's see, let's run this code. Initial array has this array integer elements like which are in random order, like starting from 50. You see, somewhere 199 is there, 65 is there, 88 is there, 62. They are in random order, guys. Now let's run this and print this array after sorting here. Let's run this. You see, after sorting, you see all the elements of the array got sorted in ascending order. 21, 21, 25, 33, 41, 50, 62, 65, 84, 119. So using the quick sort algorithm, we are able to sort the array elements by using this logic in ascending order here. So hope guys you understood how to write a Java program to implement this quick sort algorithm for sorting the array elements in ascending order. So that's it guys. Thank you. Bye.